All right, so if we look here, question number 16 on the back page, says an unknown compound contains 50% sulfur, 50% oxygen. Determine the empirical formula and show mathematical calculations to support your answer. All right, so I'm going to do this on another piece of paper because that's so tiny you can hardly see the print on the camera. All right, so 16 on that Pogil. It's 50% sulfur, 50% oxygen. All right, so let's start by describing what the empirical formula tells you. Do you remember? What was the definition for empirical formula? It's reduced to lowest terms, right? And how is it obtained? What kind of information were you given to obtain this empirical formula? What does the word empirical actually mean? Experimental. It is determined from experimental data. And the kind of experimental data that you actually have to get in order to come up with this formula is percent composition information. Okay? Okay, so here are the rules. So when you're coming up with an empirical formula from this kind of data, the first thing that you're going to do is you're going to assume that you have 100 grams of the sample. All right, well, why do you want to assume that you have 100 grams of the sample? All right, so if 50% of my sample is sulfur, right? How many grams are sulfur? What's 50% of 100? 50. By assuming that you have 100 grams of the sample, what this allows you to do is call percentages grams. All right? Because if you assume, right, percentages then equal gram. So what you do is you start off by writing 50 grams sulfur, 50 grams of oxygen. Okay? Now, what do grams mean to me? Absolutely nothing. What is the unit that's king for me? Mole. So once I rewrite these values that I'm given as grams, I take grams and I convert them to moles. All right, so that's a simple little fence post, right? Over here, 1 mole sulfur, how much does that weigh? All right, look on the periodic table. What is that, 32.01? And then for oxygen, 1 mole of oxygen weighs 16 grams. All right, so 50 divided by 32 is 1.56. And then 50 divided by 16 is 3.13. Now, step 3. The empirical formula is basically a ratio of one atom to another reduced to lowest terms, right? So it's a ratio. So guess what we need to do now? We need to figure out a ratio of this stuff, sulfur, to that stuff, oxygen. Because this should be in moles of sulfur. This should be in moles of oxygen. All right? In order to calculate that ratio, what you're going to do is you're going to take all of your answers and divide them by the smallest answer. So divide all of your answers from step 2 by the smallest answer. All right, so which is the smallest answer? Is it 1.56 or 3.13? What is it, kiddos? It's 1.56. I'm going to divide both of those by 1.56. So 1.56 over 1.56 is? So there's 1 sulfur in this formula. What's 3.13 divided by 1.56? It's roughly, it's 2 oxygens in that formula. And so what's my formula then? SO2. Okay? Now, what if this had been something different? What if the calculation had given me that I had 1 sulfur and 2.5 oxygens? What would I do at that particular point? Would I round that up to 3? No. Okay? If the answer that you get up here is just a couple hundredths off from a half or a whole, round it to the half or the whole, okay? But if the answer that you get up here is a tenth off or more, then what you need to do is try to figure out what to multiply that by to turn it into an integer. So what would you multiply 2.5 by to turn it into an integer? 2. So I would have to multiply both of those values by 2. So this would be 2s50, and then therefore the formula would be S2O5. Now this doesn't really exist, this is just an example for you to see how to do the math. So basically, after you divide all your answers by the smallest, these are your subscripts, provided they're integers. All right. The fourth rule that I'm going to have you write down, you're not always going to use, but potentially you use this rule. Potentially, you might have to multiply all your answers by the same factor to make them integers. Okay? So let's do question 17 together, and then at that point I'm going to stop and let you finish this Pogil on your own, and that includes the extension. I'd like for you to do the extension as well. Okay? That's going to be homework in lieu of what was on Blackboard. All right, so question 17 says, I've got an unknown compound that contains 43.6% phosphorus and 56.4% oxygen. Determine the empirical formula, show math to support your answer. All right, so again, 17. I'm going to assume that I've been given 100 grams of this compound. When I assume that, what does that allow me to do? Instead of calling them percents, I'm going to call them grams. So I've got 43.6 grams of P, 56.4 grams of O. All right, what does the gram unit mean to me? Absolutely nothing. So the first thing I'm going to do is convert to mole. 1 mole of phosphorus, how much does that weigh? I can't see. 30.97. 1 mole of oxygen weighs 16 grams of O. Okay. All right, so let's do 43.6 divided by 30.97. All right, my calculator says that the answer should be 1.41 mole P. And then the bottom is 56.4 divided by 16, or 3.53 mole O. All right, now what do I do? Divide by 1.41. That's 1. 3.53 divided by 1.41 happens to be 2.5. Okay? So now what do? Times by 2. And this is where people goof up. Usually they'll only multiply this bottom number by 2, but if you do it to one guy, you got to do it to the other guy too. All right? You have to do it to both of them. All right? So what's 2.5 times 2? It is now an integer, right? What's 1 times 2? So you got 2 phosphorus and 5 oxygens in this formula. So what is that formula? P2O5. Okay? That's how you come up with the empirical formula. Okay? All right, so your task is to finish the rest of this puzzle. All right, including the extension.